June 1944, Pontiac, Michigan, 3 weeks before D-Day would forever change the course of World War II, and 6 months after Rod Stevens Jr. had completed what seemed like an impossible task of transforming a standard military truck into an amphibious vehicle that could swim through ocean waves and drive up beaches to deliver critical supplies directly from ships to fighting men on hostile shores. The 42-year-old yacht designer stood in the cavernous manufacturing facility of the Yellow Truck and Coach Manufacturing Company, watching assembly line workers bolt together the strange hybrid vehicles that military planners had initially rejected as impractical fantasies, but which had become so essential to invasion planning that production ran 24 hours daily to meet the insatiable demand for what soldiers had begun calling WKWs, or simply ducks, amphibious trucks whose ungainly appearance belied their revolutionary capability to bridge the gap between naval vessels and inland battlefields without requiring the vulnerable transfer points that traditional landing craft created. Stevens had designed the WKW's hull in just 38 days during spring 1942, working alongside engineers from General Motors and colleagues from his naval architecture firm Sparkman and Stevens to create a watertight steel box that could enclose the chassis of a GMC 2.5-ton truck while adding propulsion systems that allowed the vehicle to swim at 6 miles per hour through open ocean and then transition seamlessly to land operation at highway speeds approaching 50 miles per hour, a dual capability that seemed almost magical to military planners who had struggled for years with the logistical nightmare of amphibious operations, where supplies had to be transferred from large ships to landing craft to beaches to trucks in vulnerable staging areas that enemy artillery could devastate with devastating efficiency. The WKW had proven itself brilliantly during the Sicily invasion in July 1943, when nearly 1,000 of the amphibious trucks had delivered troops and supplies directly onto hostile beaches, while conventional landing craft struggled with shallow water and rough seas. And subsequent operations in Italy and the Pacific had confirmed that Stevens' awkward-looking creation represented one of the war's most valuable innovations, a vehicle that Dwight Eisenhower would later describe as among the most important pieces of equipment America produced during the entire conflict. But standing in the Pontiac factory that June morning, Stevens was not watching WKW production, but rather observing the assembly of an even more audacious, amphibious vehicle, the Ford GPA or Seep, a swimming jeep that Stevens had also designed and which represented an attempt to provide frontline combat units with their own amphibious capability, rather than depending on the larger WKWs that required dedicated transportation companies to operate. A swimming jeep that could theoretically allow reconnaissance units and forward elements to cross rivers and approach beaches with the mobility and independence that standard jeeps provided on land, but extended into aquatic environments where waterways became highways rather than obstacles, requiring engineers to bridge before operations could continue. The Ford GPA represented both the promise and the peril of wartime innovation, a vehicle conceived in the flush of excitement following the WKW's success, but whose execution revealed how difficult it was to miniaturize amphibious capability into a package small enough to retain the Jeep's legendary agility while maintaining sufficient buoyancy and seaworthiness to operate in the challenging conditions that combat demanded. Stevens had approached the GPA design with the same principles that guided his WKW work, creating a boat-shaped hull that wrapped around a modified Jeep chassis, much as the WKW's hull enclosed a truck frame, adding a propeller driven by power takeoff from the engine and a rudder for steering through water, incorporating bilge pumps to handle the inevitable leaks that occurred when thin steel hulls designed primarily for weight savings rather than watertight integrity encountered the stresses of surf and combat. The GPA weighed 3,500 pounds compared to the standard Jeep's 2,400 pounds, that extra 1,500 pounds representing the hull, propulsion system, and waterproofing necessary to transform a land vehicle into an amphibian, weight that compromised the Jeep's renowned agility on land, while failing to provide the freeboard and cargo capacity necessary for truly effective amphibious operations. In water, the GPA sat dangerously low, its deck barely above the waterline even in calm conditions, meaning that even modest waves could swamp the vehicle, and that any significant cargo or passenger load pushed the deck below water level entirely, creating situations where GPA crews found themselves essentially sitting in bathtubs that threatened to sink with every wave that broke over the low sides. The military had ordered over 12,000 GPAs during 1942 and early 1943, believing that swimming jeeps would prove as revolutionary as the WW had been, but combat experience quickly revealed the GPA's fundamental limitations, and by late 1943 production had been cancelled with thousands of the amphibious jeeps sitting in depots unused because combat units that received them discovered they were too heavy and underpowered for effective land operations. While being too unstable and low freeboard for safe amphibious work, vehicles that satisfied neither the requirements of conventional jeeps nor the demands of proper amphibious craft, and which therefore represented an expensive lesson in how difficult it was to create successful hybrid vehicles that attempted to master two fundamentally different operating environments. Some GPAs saw service in the Pacific, where island-hopping campaigns created situations where river crossings and short water transits justified accepting the vehicle's limitations, and a few were used by reconnaissance units in Europe for crossing rivers during the rapid advances that followed the Normandy breakout. But the GPA never achieved the success that its designers had envisioned, and most military planners regarded it as a well-intentioned failure that demonstrated the perils of trying to extend proven concepts beyond their natural limits. The contrast between the WKW's brilliant success and the GPA's disappointing performance illustrated fundamental truths about amphibious vehicle design that engineers would spend subsequent decades learning and relearning as they attempted to create vehicles that could operate effectively in multiple environments without compromising performance in any single domain. The WKW succeeded partly because it was large enough to accommodate the weight penalties that amphibious capability imposed, without losing the load-carrying capacity that made trucks valuable, could achieve adequate freeboard despite its weight, because its hull volume was substantial enough to provide buoyancy for both the vehicle and significant cargo, maintained acceptable land performance despite added weight because its truck chassis was inherently robust and powerful enough to handle the burden, and benefited from relatively forgiving operational requirements that emphasized cargo delivery rather than tactical mobility, and therefore accepted limitations in water speed and maneuverability that would have been unacceptable in combat vehicles expected to operate under fire. The GPA failed partly because jeeps operated at the opposite end of the size and capability spectrum, vehicles whose value derived from being light and nimble rather than strong and capacious, whose chassis lacked the power margins necessary to accommodate significant weight increases without compromising performance, whose small size meant that achieving adequate freeboard while maintaining ground clearance created geometric challenges that Stevens' hull design couldn't fully resolve, and whose tactical role demanded mobility and responsiveness that the swimming jeep's compromised land performance couldn't deliver. Military planners learned from these contrasting experiences that amphibious capability couldn't simply be added to existing vehicles through clever engineering, but rather required fundamental design integration where the amphibious mission shaped every aspect of vehicle architecture from the beginning, lesson that would influence post-war amphibious vehicle development and lead to purpose-built designs like the WKW's successor vehicles, rather than continued attempts to create amphibious versions of standard military trucks or jeeps. But in June 1944, as D-Day approached, these lessons remained partially learned, and military forces preparing for the Normandy invasion included both the proven WKWs that would play starring roles in the operation, and small numbers of GPAs whose presence reflected lingering hopes that the swimming jeeps might find useful applications despite their known limitations, vehicles whose appearance on Normandy beaches would indeed shock German defenders, though not necessarily for the reasons American planners had anticipated. The German defensive positions overlooking Normandy's invasion beaches had been constructed according to principles that assumed amphibious assaults would follow predictable patterns established during earlier operations in the Mediterranean and Pacific, patterns where landing craft delivered troops and light equipment directly onto beaches, while heavier cargo required artificial harbors or captured ports before it could be brought ashore in quantities sufficient to sustain major operations. German engineers had studied Allied amphibious techniques exhaustively, analyzing intelligence reports and captured equipment to understand how American and British forces conducted these complex operations, identifying what they believed were inevitable vulnerabilities in the transfer process, where supplies moved from ships to landing craft to beaches, vulnerabilities that German artillery and machine guns could exploit to create catastrophic bottlenecks that would doom invasion attempts by preventing the steady flow of ammunition, fuel, and equipment that attacking forces required to maintain. Momentum beyond the initial beachhead. Field Marshal Erwin Rommel, commanding German defensive preparations in France, had emphasized the importance of destroying invasion forces on the beaches before they could establish themselves inland, arguing that once Allied forces broke through coastal defenses, the war would be lost because German forces lacked the mobility and resources to contain a major Allied lodgment in France. Arguments that led to massive construction programs, creating the elaborate fortifications and obstacles that defenders hoped would turn Normandy's beaches into killing grounds, where Allied amphibious capabilities would prove inadequate for the challenges that German defenses presented. Among the intelligence that German planners possessed were reports about DUKWs observed during Sicily and Italy operations, reports that described strange amphibious trucks that could swim from ships to shore, but which German analysts had apparently dismissed as specialized equipment whose limited numbers and ungainly performance meant they represented curiosities, rather than game-changing capabilities that would fundamentally alter amphibious warfare's basic dynamics. German defensive plans therefore continued to assume that Allied logistics would depend on vulnerable beachheads where supplies accumulated, before being distributed inland, beachheads that German artillery could target and disrupt, creating the delays and confusion that might allow German counterattacks to drive invaders back into the sea before they could consolidate positions strong enough to withstand determined resistance. What German planners failed to anticipate was that American forces would arrive at Normandy with nearly 2,000 DUKWs whose capability to deliver supplies directly from offshore ships to inland dumps would largely bypass the vulnerable beach transfer points that German defensive doctrine assumed were inevitable, vehicles whose impact on invasion logistics would prove so significant that some historians would later argue the DUKW's contribution to D-Day's success rivaled that of more celebrated equipment like the Sherman tank or the C-47 transport aircraft, argument that reflected recognition that battles were won or lost based on logistics as much as firepower, and that the DUKW's ability to maintain supply flow under conditions where conventional methods would have created catastrophic bottlenecks represented innovation as important as any tactical or technological advantage that Allied forces enjoyed. The pre-dawn darkness of June 6, 1944, found thousands of American soldiers crowded aboard landing craft and DUKWs rolling through heavy seas toward beaches codenamed Utah and Omaha, men whose training had emphasized that the first hours of invasion would determine whether the liberation of Europe succeeded or whether Allied forces would suffer catastrophic defeat that might delay victory by years and cost hundreds of thousands of additional lives. Among those soldiers were the crews of DUKW companies assigned to deliver the first waves of critical supplies immediately behind assault infantry, men who had trained for months to operate the amphibious trucks under combat conditions, but who now faced the reality of driving into hostile fire while navigating through obstacles and chaos that no training exercise could fully simulate. Men who understood that their mission of delivering ammunition to forward units might prove as important to D-Day's outcome as the bravery of infantry, attacking German positions or the skill of naval gunners suppressing defensive positions. Technical Sergeant James Wheeler commanded a DUKW loaded with artillery ammunition, bound for batteries supporting the assault on Omaha Beach, and as his vehicle wallowed through 4-foot swells that threatened to swamp even the DUKW's relatively high freeboard, he reflected on the improbable journey that had brought him from his family's Iowa farm to this moment approaching. A hostile shore in a truck that floated. Remembered the skepticism he'd felt when first assigned to amphibious truck duty, and told he'd be driving a vehicle that could swim through ocean and then motor inland, as if water and land were merely different types of roads requiring the same basic driving skills, applied with different techniques. Wheeler had participated in DUKW operations during the Sicily invasion, where he'd learned that swimming a loaded DUKW through surf required judgment and nerve equal to any combat situation, had seen DUKW swamp and sink when overloaded or poorly handled, had witnessed the terror of crews trapped in sinking vehicles, and the courage of those who continued missions despite knowing that mechanical failure or enemy fire could send them to the bottom with no possibility of escape from hulls that became steel coffins once they filled with water. Now approaching Normandy in darkness, with the sound of naval gunfire and German defensive fire creating a cacophony that made communication nearly impossible, Wheeler focused on maintaining position in the formation of DUKWs that would deliver the first ammunition resupply to artillery, batteries whose guns would be essential for suppressing German positions and allowing infantry to push inland from the beaches where casualties already mounted as the assault waves encountered fiercer resistance than planners had anticipated. The German defenders positioned in concrete bunkers and fortified positions overlooking Omaha and Utah beaches had prepared themselves for the amphibious assault that intelligence suggested would eventually come, had studied reports from Sicily and Italy, where Allied landing operations had provided lessons about tactics and equipment that German military planners believed would allow them to predict and counter whatever methods the invasion forces employed when they finally attempted to breach Fortress Europe's coastal defenses. German officers commanding the beach defenses had reviewed intelligence photographs showing standard landing craft and amphibious tanks that could swim short distances before transitioning to land operation, equipment that fit within established categories of amphibious warfare technology, and which therefore could be addressed through conventional defensive measures involving concentrated artillery fire at the waterline, where amphibious vehicles were most vulnerable during their transition from sea to land. Mines and obstacles placed to channel landing craft into killing zones, where German machine guns and mortars could destroy them before troops could establish beachheads, and defensive planning that assumed the Allies would require extended periods to build up supplies and reinforcements, because the absence of captured ports would force them to depend on vulnerable beach transfer points where cargo moved from ships to landing craft to shore in time-consuming sequences that German artillery could disrupt. What German defenders were utterly unprepared for on the morning of June 6, 1944, was the sight of hundreds of American trucks driving directly out of the ocean onto the beaches, vehicles that appeared to defy all normal logic about what was mechanically possible, trucks that swam through rough seas with loads of ammunition and supplies, and then simply drove up the beaches and inland as if the transition between water and land represented no particular obstacle or challenge. Vehicles whose very existence seemed to represent American technological capability that exceeded anything German engineering had achieved or even seriously attempted. The psychological impact of watching DUKWs emerge from the sea proved nearly as significant as their practical contribution to invasion logistics, creating moments of stunned disbelief among German soldiers who had been taught that German engineering represented the pinnacle of military technology, and who now confronted evidence that Americans had developed amphibious capabilities that German designers had dismissed as impractical or impossible, disbelief that contributed to the broader demoralization that accumulated through D-Day, as German defenders realized that Allied material superiority extended far beyond simple numerical advantages to include innovations that fundamentally altered the operational possibilities for amphibious warfare in ways that German defensive doctrine had failed to anticipate or prepare for adequately. A German lieutenant named Friedrich Hoffmann, commanding a platoon of infantry defending positions overlooking Utah Beach, later described in his memoirs the shock of watching what he initially believed were boats approaching the shore, only to realize that these vessels were actually trucks that drove directly out of the water without pausing or requiring any visible preparation for land operation. Trucks that seemed to mock every assumption about the limitations that physical reality imposed on mechanical vehicles, and that suggested American engineers had achieved something that bordered on the miraculous, given the fundamental incompatibility between the requirements for effective boats and effective trucks that German technical experts had always insisted made true amphibious vehicles impossible to create, except as compromised hybrids, useful only for specialized niche applications. Hoffman's incredulous observation that the Americans have invented trucks that swim like ships and then drive away as if nothing unusual had happened captured the cognitive dissonance that many German defenders experienced when confronting the DUKW, dissonance that reflected not just surprise at unexpected technology, but deeper recognition that American industrial capacity and engineering creativity had produced capabilities that German forces could not match even when fighting from prepared defensive positions, with all the advantages that defenders theoretically enjoyed over attackers who had to project power across an ocean and establish themselves on hostile shores, while German artillery and machine guns attempted to destroy them before they could consolidate their beachheads. Technical Sergeant Wheeler's DUKW reached Omaha Beach approximately 40 minutes after the first assault waves had landed, arriving to find a scene of chaos and carnage that exceeded anything his training had prepared him to witness. With burning landing craft littering the shoreline, bodies floating in the surf and scattered across the sand, disabled tanks and vehicles creating obstacles that complicated movement inland, and German defensive fire continuing to exact terrible casualties from soldiers, pinned down behind whatever cover the beach offered, while they waited for artillery and naval gunfire to suppress the bunkers and strong points that dominated the beach with overlapping fields of fire. Wheeler had been ordered to deliver his cargo of artillery ammunition to battery positions that were supposed to have been established inland by the time resupply DUKWs arrived, but the unexpectedly fierce German resistance had prevented artillery from moving off the beach, and the batteries remained near the waterline, exposed to German fire and desperately needing the ammunition that Wheeler carried if they were to provide the fire support that would allow infantry to break through German defensive positions and push inland before German reinforcements could arrive to drive the invasion back into the sea. As Wheeler's DUKW rolled up the beach, German machine gun fire rattled off the vehicle's steel hull, and several rounds punctured the cab, one passing so close to Wheeler's head that he felt the air displacement and realized that he had survived by perhaps 6 inches the difference between living and dying, the arbitrary margin that characterized all combat and that made survival as much about luck as about skill or courage. Wheeler delivered his ammunition to the artillery positions and immediately headed back to sea to retrieve another load from the supply ships anchored offshore, beginning the shuttle runs that DUKW companies would maintain throughout D-Day and the following weeks, runs that became so routine despite continued German fire that crews developed almost mechanical efficiency in their operations, driving through the surf, loading cargo from ships, returning to shore, delivering supplies to forward dumps, and repeating the cycle again and again until exhaustion or mechanical failure or enemy fire forced breaks that were kept as brief as possible, because the invasion's success depended absolutely on maintaining the flow of ammunition, fuel, and equipment that sustained combat operations. The German observation posts that survived the initial naval bombardment tracked these DUKW operations with growing alarm as they reported to their commands that Americans were bringing supplies directly from ships to inland positions without using the vulnerable beach staging areas that German artillery had pre-registered and that defensive plans had assumed would create bottlenecks that could be exploited to disrupt Allied logistics. Reports that suggested the invasion's supply situation was more robust than German planners had anticipated, and that the window for decisive counterattacks was closing more rapidly than expected because American forces were building combat power faster than the timetables that had guided German defensive preparations. By the afternoon of D-Day, Wheeler had completed 4 round trips between ship and shore, delivering nearly 15 tons of ammunition and other critical supplies, and he had witnessed the DUKW's value not just in the tonnage delivered but in the speed and flexibility with which supplies could be moved directly to where they were needed without the time-consuming transfers that conventional logistics required. Speed. That meant artillery batteries never ran short of ammunition despite firing thousands of rounds to suppress German positions, and that meant infantry received mortar rounds and small arms ammunition fast enough to maintain their attacks rather than having to pause while supplies accumulated at beach transfer points that German artillery could target. The WW companies operating at Normandy would eventually deliver over 40% of all supplies that came ashore during the first critical weeks of the invasion. Proportion that shocked even American logisticians who had been confident in the DUKW's capabilities but who had not anticipated just how completely these amphibious trucks would transform the invasion's logistics dynamics. And German intelligence reports analyzing the Normandy operations consistently identified the DUKW as among the most significant factors enabling Allied forces to build combat power rapidly enough to overcome the initial German advantages in defensive positions and local force concentrations. The contrast between the DUKW's spectacular success and the GPA's disappointing performance became starkly evident during the Normandy operations, where a small number of Ford GPAs had been included in the invasion force despite their known limitations, vehicles whose presence reflected lingering hope that swimming jeeps might find useful applications that would justify their continued deployment, despite earlier disappointments in Sicily and Italy, where combat experience had revealed the fundamental flaws in the GPA's design that made it unsuitable for most military purposes. Several GPAs were loaded onto landing craft for D-Day operations with vague missions involving reconnaissance and river crossing support. But their actual employment proved problematic and their contribution minimal compared to the DUKWs that were proving indispensable for maintaining supply flow under the challenging conditions that characterized the invasion's first days. One GPA was famously photographed driving through shallow water near Utah Beach on D-Day +2, an image that would appear in subsequent histories as evidence of amphibious jeeps participating in the invasion. But this single photograph obscured the reality that most GPAs saw little meaningful use during the Normandy campaign because their low freeboard made them unsuitable for the rough seas that characterized D-Day conditions, and because their compromised land performance meant they couldn't compete with standard jeeps for reconnaissance and liaison duties that represented their theoretically intended roles. The few GPAs that did see action during the Normandy campaign were primarily used for crossing rivers during the advance inland after the initial beachhead had been secured. Situations where their ability to swim across waterways whose bridges had been destroyed provided modest value, though even these applications were limited because the GPA's carrying capacity was so restricted that they could transport little beyond their crew and minimal equipment, making them far less useful than the standard landing craft and pontoon bridges that engineers deployed for crossing major water obstacles. One instance where a GPA proved valuable occurred when a reconnaissance unit needed to cross a swollen river to investigate German defensive positions on the opposite bank. Mission, where the swimming jeep's ability to ferry small teams across the water without requiring time-consuming bridge construction allowed the unit to gather intelligence rapidly enough to influence tactical planning, but such examples remained exceptional rather than typical, and most officers who had access to GPAs found them more trouble than they were worth, given their mechanical unreliability and their tendency to swamp in anything beyond perfectly calm water conditions. The GPA's failure at Normandy represented the final nail in the coffin for a vehicle that had never lived up to its designer's hopes, and production had already been cancelled by the time D-Day occurred, leaving the swimming jeeps as curiosities that would occasionally appear in historical photographs, but which would be largely forgotten by soldiers and historians who focused instead on the successful innovations like the DUKW that had genuinely transformed amphibious warfare. The contrast between these two amphibious vehicles illustrated fundamental lessons about military innovation that would be studied by subsequent generations of designers, lessons about the importance of understanding operational requirements before attempting technical solutions, about the dangers of assuming that successful concepts could be scaled up or down without careful analysis of how size affected performance characteristics, about the necessity of realistic testing under combat conditions before committing resources to mass production, and about the value of maintaining flexibility to cancel or modify programs when testing revealed fundamental limitations that no amount of incremental improvement could overcome. Lessons that the American military's approach to research and development had learned imperfectly during WW2, but which would become increasingly embedded in post-war procurement processes that emphasized prototyping and operational testing before full-scale production commitments. The German military's response to the DUKW's appearance at Normandy evolved from initial shock through attempted tactical adaptation to eventual resigned acceptance that this American innovation represented yet another example of the material and technological superiority that characterized Allied operations and that made German victory increasingly improbable despite continued fierce resistance that would extend the war for nearly another year of bitter fighting across France and into Germany itself. German intelligence officers interrogated captured DUKW crews to understand the vehicle's capabilities and limitations, learning about payload capacities and operating procedures and the logistics networks that supported their operations. Information that was compiled into reports that attempted to develop countermeasures, but which ultimately concluded that the DUKW represented a systemic advantage that couldn't be negated through tactical adjustments alone. That addressing American amphibious capabilities would have required German development of equivalent vehicles or fundamentally different defensive approaches that were beyond Germany's capacity to implement, given the resource constraints and industrial disruptions that characterized the final year of the war, when Allied bombing had devastated German production facilities and the loss of conquered territories had eliminated access to raw materials and labor that German war economy had depended upon. Some German units attempted to prioritize DUKW targets, directing artillery and machine gun fire at the amphibious trucks in hopes that destroying them would disrupt Allied supply lines. But the DUKW's mobility and the volume of traffic meant that even successful attacks rarely achieved significant operational impact because destroyed vehicles were quickly replaced and supply flow continued with minimal interruption, demonstrating that the DUKW's value derived partly from individual vehicle capability, but more importantly from the systemic approach to amphibious logistics that American planners had developed around Stevens' basic design. German officers' memoirs written after the war frequently mentioned the DUKW as an example of American engineering ingenuity that had surprised them, with several acknowledging that they had never imagined trucks could be made truly amphibious in ways that would prove operationally significant, rather than merely representing technical curiosities of limited practical value. And some reflected ruefully that German engineering culture's emphasis on technical perfection and elegant solutions had perhaps blinded German designers to the kind of pragmatic problem-solving that characterized American approaches to equipment development, where good enough for operational purposes often proved more valuable than theoretically optimal designs that required resources or manufacturing capabilities that wartime constraints made unavailable. Field Marshal Erwin Rommel, in his final reports before being wounded in July 1944, specifically cited the DUKW's contribution to Allied logistics as evidence that American industrial capacity had produced innovations that gave Allied forces capabilities that German defenders couldn't match even when fighting from prepared positions. With all the tactical advantages that defensive operations theoretically provided, observations that contributed to Rommel's growing conviction that Germany's military situation was hopeless, and that continuing the war would only multiply German casualties without any possibility of achieving victory or even favorable peace, terms that might preserve something of Germany's territorial integrity and political independence. The psychological impact of the DUKW extended beyond its practical logistics, contribution to affect German morale more broadly, as soldiers and officers recognized that America's ability to develop and mass-produce such specialized equipment indicated resource advantages so overwhelming that no amount of German tactical skill or fighting spirit could overcome the material disparities that characterized the struggle between German forces defending occupied Europe and Allied armies whose equipment and supplies seemed limitless compared to the increasing shortages that plagued German units as the war progressed and Germany's economic situation deteriorated under the combined pressure of Allied bombing, territorial losses, and the unsustainable military expenditures that total war demanded. The long-term legacy of the DUKW extended far beyond its immediate contribution to D-Day's success, influencing post-war amphibious vehicle development and establishing principles that would guide military planning for decades, as armed forces worldwide recognized that amphibious operations required specialized equipment that could bridge the gap between ships and inland battlefields without depending on vulnerable transfer points that enemy fire could disrupt. Rod Stevens Jr. returned to civilian yacht design after the war, his reputation enhanced by the DUKW's success, though he remained characteristically modest about his contribution and consistently emphasized the collaborative nature of the development process that had involved dozens of engineers and countless production workers whose efforts had transformed his basic hull design into a vehicle that could be manufactured by the thousands and operated reliably under combat conditions that tested both mechanical durability and crew endurance. General Motors produced approximately 21,000 DUKWs during the war years, vehicles that saw service not just in Europe, but throughout the Pacific Theater, where island-hopping campaigns created countless situations requiring amphibious supply operations. And the DUKW's performance was so impressive that it remained in military service for decades after the war ended, being reactivated during the Korean War when amphibious operations at Incheon and elsewhere created renewed demand for vehicles that could deliver supplies directly from ships to shore without requiring port facilities or extensive beach infrastructure. Surplus DUKWs found civilian applications after the war, with some being purchased by tourist companies that operated them as amphibious sightseeing vehicles in cities like Boston and London, where their ability to drive on streets and then splash into rivers or harbors created novelty experiences for tourists who enjoyed the transition from land to water travel. Uses that demonstrated the DUKW's fundamental soundness as a design and its capability to operate reliably even decades after manufacture when maintained properly and operated within its design parameters. The principles that Stevens had embodied in the DUKW's design influenced subsequent amphibious vehicle development, including the Marine Corps' SIR LVTP series that evolved into the vehicles used during Vietnam and later conflicts, though designers learned that creating successful amphibious vehicles required accepting inherent compromises between water and land performance rather than expecting to achieve excellence in both domains simultaneously, lesson that Stevens himself had understood and that the GPA's failure had reinforced, through negative examples showing what happened when designers tried to create amphibious versions of vehicles whose basic architecture was incompatible with the requirements for effective water operations. Modern amphibious vehicles continue to face the same fundamental trade-offs that Stevens grappled with in 1942, balancing between seaworthiness and cargo capacity and land mobility in ways that require careful analysis of operational requirements and realistic assessment of technical possibilities. Though contemporary materials like aluminum and composite structures and propulsion technologies including water jets and more efficient propellers allow capabilities that would have seemed impossible to WW designers working with the steel hulls and mechanical drive systems that represented the state of the art. During the 1940s, when weight and power limitations imposed constraints that modern technology has partially overcome without eliminating the fundamental challenges of creating vehicles that can operate effectively in both aquatic and terrestrial environments. The DUKW's appearance at Normandy shocked German defenders not simply because it represented unexpected technology, but more fundamentally because it demonstrated American willingness to invest resources in developing solutions to logistical problems that German military culture tended to regard as secondary to tactical concerns, cultural difference that reflected deeper divergences between military philosophies, where American forces emphasized systematic approaches to operational challenges, while German forces relied more heavily on tactical excellence and operational art that assumed logistics would somehow be managed adequately without requiring the kind of specialized equipment and careful planning that characterized American amphibious operations. The thousands of DUKWs that rolled off assembly lines during the war years represented not just vehicles, but a comprehensive logistics system that had been designed to support specific operational requirements. System that worked because it integrated vehicle design with training programs that taught crews how to operate in both water and land environments, and maintenance procedures that addressed the unique challenges of equipment exposed to saltwater corrosion and the mechanical stresses of transitioning between amphibious and terrestrial operations, and operational doctrine that specified how DUKWs would be employed within larger logistics networks to maximize their contribution to sustaining combat operations. When German soldiers watched DUKWs drive out of the sea at Normandy, they were witnessing not just an engineering achievement, but evidence of American systematic approach to military problems that analyzed requirements and developed integrated solutions rather than depending on battlefield improvisation and tactical virtuosity that German military tradition celebrated, but which proved inadequate when confronting the material realities of industrialized warfare, where production capacity and logistical efficiency ultimately mattered more than individual courage or tactical brilliance. Sobering lesson that Normandy taught, and that subsequent German defeats through the final year of the war repeatedly reinforced, as American material advantages compounded and German resources dwindled toward the inevitable conclusion that would come with surrender in May 1945. The story of the DUKW ultimately reveals something essential about how technological innovation contributes to military success, demonstrates that even relatively simple concepts like putting a truck in a boat can have profound operational impact when implemented systematically and employed as part of comprehensive approaches to solving logistical challenges, and shows that the side that wins wars is often not the one with the most elegant technology or the most sophisticated tactical doctrine, but rather the side that most effectively translates industrial capacity into practical solutions for the mundane problems of moving supplies and maintaining forces under combat conditions that test organizational competence as much as individual bravery. Rod Stevens' DUKW represented American pragmatism at its finest, a design that sacrificed theoretical elegance for practical effectiveness, and that succeeded because it addressed real operational needs rather than attempting to achieve technical perfection that combat conditions made irrelevant. And the DUKWs that emerged from the ocean at Normandy to shock German defenders symbolized broader American advantages in systematic problem-solving and industrial execution that would ultimately prove decisive in a war where victory depended on sustaining military operations over time and distance that required logistics capabilities exceeding anything previous conflicts had demanded. For the soldiers who witnessed DUKWs driving out of the sea on June 6, 1944, whether they were American troops grateful for the ammunition and supplies these vehicles delivered, or German defenders stunned by technology they had never imagined possible, the amphibious trucks became symbols of how industrial warfare had transformed combat from contests of individual courage and tactical skill into struggles where organizational capability and logistical efficiency determined outcomes as surely as battlefield heroism or strategic genius. Technical Sergeant Wheeler survived D-Day and continued operating his DUKW through the Normandy campaign and into the advance across France, accumulating hundreds of hours driving through surf and over beaches and along French roads. And he would later reflect that his amphibious truck represented everything that made American victory possible, the combination of innovative engineering and mass production and systematic training that allowed ordinary soldiers like himself to accomplish extraordinary things not through superhuman courage, but through competent execution of well-designed procedures using equipment that worked reliably when operated properly. Wheeler returned to Iowa after the war and never saw another WW except in photographs and at the occasional military museum, but he carried memories of those vehicles emerging from ocean waves to roll up hostile beaches as proof that American engineers had achieved something genuinely remarkable, had created machines that defied conventional limitations, and that demonstrated how creative problem-solving combined with industrial capacity could produce advantages that no amount of tactical brilliance could overcome. Lessons about the nature of modern warfare that would influence American military planning throughout the Cold War and into the 21st century, when new generations of amphibious vehicles would continue the tradition that Rod Stevens had established when he designed a truck that could swim.